Okay, so hello, welcome to this presentation on circular mass timber for construction, adhesive-free bonding of recovered timber for structural mass timber production. And this is a project that I'm working on, and it's sponsored by the Circular Economy Hub. So what does that mean? What's the project focus? What are we working on? Well, we're looking at developing an adhesive-free joining method. So to join timber via friction welding. So this is a new process. Currently, lots of adhesives are used in mass timber manufacture, and we're hoping to remove that by using a brand new process that's never been used in industry before, called friction welding. It's a process that's heavily used in for metal components or other metallics. So what are we looking to focus on? We're looking at using recovered and reclaimed timber. So reusing material that's already out in the world rather than that going to waste. And we're focusing on joints that are applicable to the structural mass timber market and applications, things like CLT, which currently rely very heavily on adhesives. So the project partners are TWI. So I'm Kate Franklin and I work at TWI. We are a research institution and work on developing technologies, especially welding technologies, for new applications and new materials. We're also working with UCL and UKCLT, who are providing material and doing the testing on this project. So why are we looking at friction welding? Well, there's a number of advantages over the current joining methods. So it's very fast. You can make joints in just a matter of seconds. It reduces the waste. So we don't have to cut off into a finger joint, which reduces the waste, but we also, in this project, are looking at using recycled material, so we're reducing the waste further again. It's a very repeatable process, so once you've got parameters set on your weld, it's almost exactly the same every single time, and it's very high strength, and there's zero addition. So when we're friction welding, we're not adding an adhesive, we're not adding, there's no fumes, there's no additional material used at all. It's just the original timber that we started with. So we've TWI have previously demonstrated feasibility on joining virgin timber using this linear friction welding process, which essentially just rubs two parts of wood together. And we've managed to achieve bonded strength comparable to adhesives in that work. So the project plan for this project was to gather some reclaimed timber and do 3 types of friction welding, so face adhesion welds, end-to-end finger welds, and end-to-end butt welds, and then also look to do some adhesive welds that we could compare those to, and then undertake assessment of those using optical and SCM imaging, shear testing, and bend testing, as well as developing and understanding the business case for undertaking friction welding in the mass timber industry. So let's have a look at the work we've done so far. So we've developed tooling to hold long lengths for end-to-end welding. So previously we were only able to hold parts that were up to 80 millimeters in length for wood. And we're now able to hold parts that are between 400 and 800 millimeters in length on the forge side, which is the part that doesn't move, and up to 500 millimeters in length on the part that does oscillate. So we've massively increased the length of the parts that we're able to hold and therefore join together to demonstrate the capabilities in terms of the length. We've also undertaken welding. So here we've got a video of us doing some end-to-end butt welds you can see that the material comes together. There's then a linear oscillation applied. Here, you get some smoke from the material as it heats, and then it's pushed together at the end of the process. And that is the whole cycle of the weld. So that's a completed end-to-end butt welding. So what are our achievements on the project so far? We've done a series of end-to-end finger welds, which have shown some successful joints. We've done a series of end-to-end butt welds. So this is where we've got a flat surface. And again, we've been able to get some really good long lengths of weld here. So in both these end-to-end finger welds and end-to-end butt welds, we've been able to get total lengths of over 800 millimeters, which is far more than anybody has ever achieved, including ourselves. And then we've also done some face adhesion welds with some recycled timber and been able to get some really good results with that as well. So all of the weld types on the project are complete that we plan to do, and we've sent those parts now for testing at UCL, like we suggest on the project plan. So some really good progress, some really good demonstrations of the work that we've been able to do, and the feasibility of this welding method has been shown here. Thank you very much for your time, and I look forward to hearing from you if you've got any further interest. Thank you very much.